Hi, I'm Mark Goodner, a program manager on the C++ team. I'm here to tell you about the Linux development with C++ workload in Visual Studio 2017. It's easy to get started. You can go from install to launch in under 10 minutes. There's no distro requirements. All that you need on the Linux machine is just SSH, GCC, and GDB. What this workload is going to allow you to do is work with your C++ code in Visual Studio. IntelliSense works with common headers provided right out of the box, and you can always add your own. Our project system allows you to control the common GCC options, and we support syncing your files to the remote Linux machine and building them natively there. You can use our project system to do this, or bring your own makefiles or build scripts. You can target not just x86 and x64 machines, but ARM as well for working with your IoT devices that run Linux. You can debug your applications in Visual Studio, including attach to process. Let's take a look at how that works. Here you can see the new installation experience for Visual Studio 2017. And what you can find if you scroll down, under Other Toolsets, you'll see Linux Development with C++. Once you have that installed, let's take a look at how that works. So within Visual Studio 2017, let's go ahead and fire up and take a look at what project types we have here. So for the Linux workload, what we have are 4 project types. We've got Blink, which is a Raspberry Pi template to help you blink an LED, get started with ARM-based development for Linux IoT-based devices. We've got Console Application, which just gives you a basic main file to start with. Empty, for you to bring in your own projects. And then Makefile, which works with your own Makefile projects on the remote build system, or Bash script, CMake, what have you. Let's go ahead and create a console app. So the first thing that pops up when you create one of these is a Getting Started page that gives you the basic documentation on what you need to know about this project type. It also brings in a main file that just outputs some text to the console. Well, let's take a look at what sort of project properties we have here. Under General, you've got your basic project properties and the output directories and the target names and things like that. We've also got the configuration type. Here you can see we're set up by default to build an application, but you could also build a dynamic library, a static lib, etc. Remote settings is where we pass the options to which target machine we're targeting, what the remote directory is that we're going to be working with, where the project directory is. We've also got our options for what compilers we're working with. These are what are basically available off of your path. If you need to use a more specific compiler, you could specify that here, including the path. Under debugging, we've got other options like things that you might need to run before launching the application, things like exporting a display for working with graphics apps, or arguments to pass to your program when you start that up. We've also got other options here for things like setting up other include directories under the VC directories, or whether or not you want to copy sources, and all sorts of GCC options under C++. Let's go ahead and try building this. So the first thing that happens here is you'll see is that it's going to ask me for my host name because I haven't set up a Linux connection before. So let's go ahead and grab a Azure machine that I've worked with before, and I'll grab my IP address from a previous connection I made in Bash. I'll drop that in there, give it my username. And then we support password or private key. This one I'm using private key. And we can go ahead and connect. Now that saves that connection. It's copying my sources remotely up to Azure, up to the cloud, and where it's going to build them. You can see now the output of all of that happening up there. Now it comes back, and there I am. I'm debugging an application running up in Azure, and I can now step through my code, and you can see in my output window that there's the output from my application. And if the Linux console window doesn't come up, you can find it under the debug menu under Linux console. Another thing we can do with the Linux workload is attach to a running process on a remote Linux machine. So let's just create something really quick here. And we'll just take what we already have, and we'll just make that run forever so that we have a chance to attach to it. So now that I save that, I can just go ahead and build that on the remote. So it'll copy the change sources up there and build it. I can switch over to Bash for Windows and log into that remote Linux machine. And now what I can do, as you can see, this is my output directory that was specified in Visual Studio. And so I can go ahead and move down in there into my output directory, and you can see there's my output. So let's go ahead and run that. And you can see it's just going to run and spit that out forever. Let's go back to Visual Studio, and under the debug menu, I can come in here and I can go to Attach to Process. And I can change my transport to SSH. This is a new option. And this uses the same connections that were specified earlier. So when I grab my qualifier, you'll see that it saved the connection information for the Linux machine that I logged into before. And so now I can set that. And it's reached up there. And now it's pulled down the list of all of the running processes on that machine. And now I can go ahead and select the process that I'm going to attach to here. And we'll go ahead and see if we can see that happen and attach to that. And I'm going to specify that I'm using native. What you can see is now the output has stopped because I've attached and hit a breakpoint. And if I remove that breakpoint and continue, you'll see that it starts running again. And I can go ahead and hit pause, and it pauses again, and then I can detach, and the application starts again. So hopefully you're going to find this very useful. Another question we get a lot is whether or not you can use the Linux workload with the Windows subsystem for Linux. And the answer is yes, you can, especially if you're on the Windows Insider Fast Track. You should be able to start SSH with no modifications. If you're not on the Windows Insider Fast Track, we've got some instructions that have you covered on our blog that can explain what you need to do in order to configure SSH to work properly for you. So I've started SSH in the Windows subsystem for Linux, so let's go ahead and connect to that. So I'll go to the connection manager. The quick launch is a great way to get there. And you can see the connection I made before to a CentOS-based machine up in Azure. So let me add my local connection. I'm configured to use IPv6, and I've set it on a different port. I'll go ahead and provide my username here and my private key. And go ahead and connect. And so now I'm connected. And I can come in, and I've got a little bit of a different project here that will show a little bit more of the Linux console window and what it's capable of. And so if I can come over here to my project properties, and under my remote settings, what I'm going to do is I'm going to make sure that I'm talking to the local Linux subsystem. And there we go. And under debugging, this application takes an argument to start. It wants a file name passed to it. So what I'm going to do is stick that in my home directory and apply these settings. And now I can go ahead and click debug. It's going to copy my sources over locally into the Windows subsystem, build them, and now you'll see I haven't hit my breakpoint, but the program has stopped execution because it's waiting for input. And you can see in the Linux console window here that I'm being asked a question. And so I can actually provide input back to my running application in Linux. And now that I did that, now I've hit the breakpoint that I set earlier, and I can inspect all of the program arguments. I can go ahead and step into that function and see what's going on. Now I can go ahead and continue, let that run. If I come back over to the Linux console, the bash window in Windows, I can see that there's my output, and I can go ahead and display what's in there. All right, the last thing I'd like to show you today is using containers with the Linux workload. Basically, all you need to do in your Docker file definition is set up the Docker image to have the dependencies that we need within Linux. So SSH, GDB, and GCC, which is provided by the Build Essentials here. Now, you need to do a little bit extra here to actually start SSH, and we'll have details on our blog about how to do this. But this is a Docker file image, or a Docker file that I just got off of Docker Hub. And so what we can do is switch over to the command line, and we can go ahead, and I've already set up this image locally here, so I can go ahead and start it. That's all it takes to get started. And you can see that it's running there, and it's got port 22 mapped to 12345. So back over here in Visual Studio, I can come into my connection manager and go ahead and add a connection to that. And use the username that was specified in the file. and connect. And now I can go ahead and come into project properties of another console app here and just make sure that I'm using that one instead of my Azure VM. And there we go. And go ahead and build that. Now it's copying those sources into the container to build. And it's going to launch it and run because I forgot to hit a breakpoint, but you get the idea. And the idea here is that you can use this to speed up your local development process by building within a container that you intend to deploy that final image later. And so you'll be working in the same environment. Your final image wouldn't have the build tools and things like that in it, but you'll be working in basically the exact same environment for consistency. Containers is something we're very interested in streamlining our workflow for here. And if you're working with containers in C++, we really want to talk to you. Well, now that we've seen how that works, what I want you to do is go to aka.ms/vslinux to learn more. That link is evergreen and it's updated with every release. Try the Linux C++ workload in Visual Studio 2017. It takes less than 10 minutes to be up and running. Use it with your Linux machines, your local or Azure hosted VMs, containers, Windows subsystem for Linux, or your Linux IoT devices. We look forward to seeing what you build with it.